here we go. 7.5b. We are solving log equations today. So let's just start. You know this. This is not what we're doing today, but it is what we're doing today. How would you set this up? What's the question you would ask yourself right now? 2 to what power, that's a question mark, equals 8, right? You're going to be using that idea with log equations, okay? You're going to be using that concept. Here are the steps that you're going to take. Very similar to what we just did. First, you need to isolate the log. Okay, get the log by itself. Sometimes that's already done for you. Then you're going to combine your logs with the properties that we talked about. Do you remember the properties? If you do log base b of m, you don't need to write these down again if you know these still. I'm just refreshing. Times log base b of n, what would that be? What do you do with addition? You multiply. So this would be log base b of m times n. Okay, so you're going to be using that quite a bit. You're going to be using the subtraction one quite a bit. What did subtraction get you? Division. So you would get log base b of m divided by n. Like I said, these are not new. You know these already. I'm just refreshing, okay? And then the third one, if we do log base b of m to the n power, what do we do with that? Put that n out in front, right? So it'd be n log base b of m, okay? So that's step 2. You'll use those properties. Step 3 is you're gonna rewrite your setup in exponential form. Okay, rewrite it in exponential form, and that will get you your solution. Let's try it. So example 1, you are going to solve. Here's the first one. This first one is log, and then in parentheses. So we are taking the log of this whole thing, okay? You're going to see 2 problems that are nearly identical, but you do them different ways. This one has parentheses, the next one does not. If I do the log of 4x minus 3 in parentheses equals 2, okay? First step, isolate the log. It is isolated. Everything, you're taking the log of everything that's there because of the parentheses, okay? Step 2, combine your logs. There's only one log there, so there's nothing to combine right now. So step 3, we're gonna write this in exponential form. What is the base of your log right now? 10, okay? If ever there is no number there, it's a 10. So we're gonna write this in exponential form. 10 to the second power equals this. 10 to the second power equals 4x minus 3. And from here, beautiful, simple algebra, right? We know how to do this over and over and over again. So you get 100 equals 4x minus 3. You're going to add 3 to both sides. So 103 equals 4x, and then you're going to divide by 4. And x comes out to 25.75. Okay, so you got to get it in exponential form. That's probably, if you can get that, you can get the rest of it. So this one looks very similar, but without parentheses, and you do it differently. Step 1 is to isolate the log. Because there are no parentheses around that, you are taking the log of 4x, not the log of 4x minus 3. So what do we need to do to isolate? Add 3. Okay, so you're going to add 3 to both sides, and you get log 4x equals 5, okay? now your log has been isolated, and there's just one log there. There's no combining that has to happen. So we're going to put it into exponential form. Remember, this is always a 10. So it's going to be 10 to what power? To the 5th power equals 4x, okay? So plug that in, 10 to the 5th power is 100,000. And again, you can do this part in your calculator. 100,000 equals 4x, divide by 4. You get x equals 25,000. Questions on that? Am I moving too quickly? You're good? Okay, letter C. What if we have 4 log 4x equals 2? Isolate the log. What do you do? Divide by 4. So we're going to divide by 4 here. We're going to divide by 4 here. We're dividing by this 4, right? Not that second 4. So we get log 4x equals 1/2 or 0.5. How do you set this up? 10 to the 1/2 equals 4x, okay? So basically you're saying the square root of 10 divided by 4. And again, plug this into your calculator, 10 to the 1/2, you get 3.1623. I don't need you to write that down. Leave it in your calculator and then divide by 4. Okay, you should be getting to 4 decimal places, 0.7906. Okay, look at that, guys. 7 minutes. Oh, now the backside. 1, 2, 3, 4, 5. You got this. Example 2 has 5 A, B, C, D, E. Okay, so now this is slightly different. You have multiple logs going on. So log, not that, log x plus log 8 equals 3, okay? When you have multiple logs, you need to figure out how to simplify it to one log. When we're adding logs together, what do? We multiply. Right, so we're gonna say this is log 8x, right? X times 8 equals 3. Now you're at the same point you were at for the last problems. What do? Exponential form. 10, right? This is our base 10. 10 to the 3rd power. 10 to the 3rd power equals 8x, okay? So you plug that in. 1,000 equals 8x, divide by 8. You get what? 125. Okay. Thank you. I appreciate that. Good. All right. Second one. Log 5 minus log 2x equals 2. Okay, so we're doing subtraction. What does subtraction get us? Division. So we are doing 1 log of 5 divided by 2x, right? We just take these two numbers and we divide them. That's going to equal 2. What's the base of our log right now? 10. So you're going to set this up in exponential form. 10 to the 2nd power equals 5 over 2x. Let's see how your algebra is. 100 equals 5 over 2x. How do you solve that? Multiply by 2x. Okay, so multiply by 2x on both sides. You get 200x equals 5. And then you're going to divide by 200. If you plug that into your calculator, x is 0.025. Look at us go, you guys. 3 left. We're only 10 minutes in. 3 more. Are we doing okay? Questions? You guys are so confident. You guys are going to just nail this quiz, huh? I'm excited. I'm so excited. Friday. Friday is a quiz. 7-4 to 7-6 quiz on Friday. All right. Since we're so confident, you try this one. Try this. Let's just work this one out. Okay, what'd you get? 10,000. Good work. Okay. Oh, wow. So we're multiplying, right? 2x times 5, so log 10x equals 5. So we are saying base 10 here, 10 to the 5th power equals 10x. Just plug in 10 to the 5th divided by 10, and you get 10,000. Letter D. No, we got an E. This one's a little trickier. We're going to take our time on this one. Oh, please. We have, like, flown through this.
Why stop now?
Why stop now? Okay. 2 log base 5 of x minus log base 5 of 3. We're doing subtraction, so this is going to bring division. What do we do with this guy? You make it an exponent. This 2 is going to go here, right? X squared. So we're going to say log base 5 of subtraction brings division, so x squared divided by 3 equals 4. Okay? Notice we have a base 5 on this one. Okay, it's not base 10 like we've been doing. So you're going to say 5 to the 4th power equals x squared over 3. Take 5 to the 4th power, 625, yep, equals x squared divided by 3. Then you're going to multiply by 3 on both sides. So you get x squared equals 1,875. Okay, and then we square root. What happens when we square root? Plus or minus. So typically, it's plus or minus. So you would plug in plus or minus. This comes out to 43.3. But here's the issue. If you go back to plug it in, you take if it's a negative 43, you have to take the log of a negative 43.3. You can't do that. So if you forget to do the plus or minus, you actually get the right answer on this problem. X would just be 43.3 because the negative is extraneous. It does not work when you go to plug it back in. So it's kind of a perk. If you do it wrong, you actually do it right. Questions on that?
Wait, so is it for all of them that you just need to pause?
Yeah, because you cannot take, when it's a log, you cannot take the log of a negative. So, yeah. All right. Last one, and this one's the doozy. We are going to draw on your prior knowledge in the best way possible. Yes. What's when it's simplified? You can't plug in, like if you plugged into your calculator up here, log base 5 of negative 43.3, it's going to tell you like domain error or something like that. So if you went back to plug in a negative, you cannot take the log of a negative number. Okay? Okay, last one looks like this. Log parentheses x minus 3 plus log x equals 1. Okay. When you are adding, you are actually what with logs here? You're multiplying. So we are saying log, I'm going to put the x in front because I like it better that way. You could put it behind, that's fine. Okay, so it looks like this. So if we rewrite this in exponential form, your base right now is 10, so we're saying 10 to the first power equals x times x minus 3. Okay, we need to solve for x. So I would distribute this. 10 equals x squared minus 3x. Is this looking familiar to you? Like, go back a few chapters. What do we have? Starts with a Q. Quadratic, a question, maybe some questions. This is a quadratic, right? When you have the x squared set up here. So what we're actually going to do to solve this for what x is we're going to factor, right? You could do we have a lot of options. You could plug it into the quadratic formula if you want, but who really wants to do the quadratic formula? I'd factor this. X squared minus 3x minus 10 equals 0. Do you remember how to factor this? Star method. So what can you multiply to get negative 3 that you can add to, multiply to get negative 10 that you can add to get negative 3? Your A term, negative 5, positive 2. So you get x minus 5, x plus 2. Okay, so when you solve this, what is your x going to be here? A positive 5. What is your x going to be here to equal 0? A negative 2. So you get 5 and negative 2, but now think back to the beginning here. If I plug a negative 2 in, that doesn't work, right? So your answer is just x equals 5 because this one does not work. Negative 2 is, we would say this is extraneous, right? You solve for it, you get an answer, but it doesn't work out. That's an extraneous answer. Fun, right? Yeah. Yes. Okay.